All right, I'm gonna go ahead and get us started. Okay, so now that you figured out what happened to the space pod, you have a new challenge. You will use what you learned about force, mass, and velocity to help a film student recreate the collision scene from a movie she saw. And we're gonna read a message about this on the next slide. So we are officially done helping Dr. Anna Gonzalez with her space pod issue that she's having. So now we're kind of moving on and we're gonna help this film student create a film. Okay, so here's her letter to us from her. Her name is Claire, and the subject says, "Help for miniature movie set." I'm a film student at Midvale University, and I heard from my aunt, Dr. Anna Gonzalez, that your experience with force and motion helped in figuring out what happened to the pod that didn't dock with the space station. I'm hoping you might be able to help me. I saw a thrilling car crash scene in Ice World Revenge, and I want to show something similar in the movie I'm making for my final project. Vehicle 1 speeds along an icy surface in Ice World Revenge. Vehicle 2 looks exactly the same, and it's parked at the edge of a cliff. Vehicle 1 collides with Vehicle 2, but Vehicle 2 does not fall off the cliff. It looks so cool in the movie and added lots of drama to the scene. I want this in my movie. I know the collision in Ice World Revenge was filmed with miniature cars and a miniature set, but when I tried to film the scene, it didn't work. Vehicle 2 shot right off the cliff. I analyzed the scene in Ice World Revenge, hoping to understand what they did. I'm attaching all the information I have. Please help me figure out why my test didn't work. Thanks in advance, Claire. Yeah, you guys, again, I'm not sharing my screen on purpose. You're supposed to follow along in the Nearpod, okay? Okay, so to help us with this new problem, we're going to watch a short video about friction, and I want you to think about these questions as we watch. They're going to show us a little experiment. So the video reflections are as follows. How do friction forces affect the motion of objects? And what can you infer about the direction of friction forces? All right, let's take a listen or watch.
We're going to do a demonstration to see how far this puck moves over different surfaces. Tile, carpet, and sandpaper. The distance a puck travels depends on the strength of the friction force. Friction is a force between an object and the surface it's moving over. Friction is always exerted in the opposite direction of an object's motion. Tile. The puck travels really far. That's because the smooth surface of the tile exerts a weak friction force on the puck. The weak friction force only causes a small velocity change, so the puck moves far across the tile. What happens when the puck travels over carpet? We can see that the puck moves a little, but not as far as the tile. That's because the carpet exerts a stronger force of friction on the puck than the tile. This causes a larger velocity change, so the puck stops sooner. Now let's see what happens when the puck travels over sandpaper. The puck quickly comes to a stop. That's because the sandpaper's rough surface exerts a very strong force of friction. This causes a really large velocity change and makes the puck stop quickly. Let's review what happened. The weak friction force exerted by the tile made the puck slide far before stopping. On the carpet, the stronger friction force made the puck stop sooner. And finally, the extra strong friction force exerted by sandpaper caused the puck to stop very quickly. Now you can see that friction causes everything to slow down, but different surfaces exert forces of different strength on the edges.
Okay, so let's review what we saw here. We saw these people set up an experiment where they were trying to figure out which surface would have the most friction. So what they did was they got 3 different surfaces. One of them that's a smooth tile surface that you see at the top, one of them that's carpet in the middle, and one that's sandpaper. So these were all of their independent variables. They used the same size puck, and they also used the same mallet along with the same amount of force applied to the mallet in each trial. And they went ahead and applied the force to the puck, and their dependent variable was how far each of the pucks went. So they wanted to see which object had the most friction, and in order to do that, they need to see the distance that each puck traveled. So what they ended up finding is right here, is that the puck that was on the tile went the furthest. And the reason for that is because it has the least amount of friction. Now, on the other hand, what you see at the very bottom is a puck that's on sandpaper. And that puck that was on sandpaper, even though it was hit with the same amount of force as the other pucks, it didn't go nearly as far, because if you've ever held sandpaper before, you know that there's a lot of friction. So it's not as easy for objects to move across. And the other point here that was made was that friction is an opposing force. It's a force that acts in the opposite direction of the movement of the object. And this is going to help us with our activity today, is this idea of friction. So remember that friction, the force between an object and its surface that it's moving over, acts in the opposite direction to an object's motion. Friction is related to one of the claims that you will consider as you learn about the challenges in setting up movie scenes. Okay, so when filming crashes and other special effects, it can be helpful to use miniature sets. It's sometimes safer, cheaper, and easier to film small-scale props instead of full-size props. And the reason that we're talking about this is because this is what this girl, Claire, who needs help with her little movie, she ends up doing. So she sets up a miniature set so that she can, I don't know, record it easily. Okay, so here you see a diagram on the left-hand side, and we're gonna keep coming back to these diagrams over and over again. So it's important that you follow along right now, because the activity is going to be all about this scene. So what you see on the left is a scene from Ice World Revenge, which is this fictional movie that our fictional person, Claire, watched. So she analyzed the scene from Ice World Revenge and sent us some information. So this is a storyboard that you see over here on the left that shows the step-by-step action that Claire observed. So let's take a look at what she saw in the movie. So if you look at the first frame, it says, on a surface that looks like ice, vehicle 1 is moving at a very high speed toward vehicle 2. Vehicle 2 is at the edge of a cliff. So you can kind of see vehicle 1, you can see those velocity tails, so it's moving pretty fast. You can also see in the image that number 2 is kind of at the edge of something that does look smooth and it's not moving. So in the second frame, it says vehicle 1 crashes into vehicle 2. So you can tell that by that yellow thing in the middle, the yellow star or whatever, that there is a collision that takes place. And me personally, I would predict that this would cause both objects to maybe even move over the edge. But what ends up happening, as you can see in the last scene on the bottom, is that neither vehicle falls over the cliff edge. In fact, number 1 seems to move in the opposite direction. So Claire thinks that this is really cool. It seems to defy the laws of physics. And she wants to recreate this, which I would imagine would probably be pretty complicated. So let's see what happens when Claire does try. Okay, well, we'll do that in a second. Okay, so here we have our scene. So to review the scene, on a surface it looks like ice. Vehicle 1 is moving at a very high speed toward vehicle 2. Vehicle 2 is at the edge of a cliff. Vehicle 1 crashes into vehicle 2, but neither vehicle falls over the edge. All right, now let's take a look at Claire's test. So this is another storyboard, but it's showing Claire's attempt to reproduce the scene that she saw in that movie. And in her test, she used the 2 model cars of the same mass and a surface on ice. So she's trying to recreate the scene. So she gathers materials that she thinks will help work. So she does ice, just like It was in the movie. She uses two objects that have the same mass for her cars, and she attempts to recreate this scene. So let's take a look at the storyboard on the left. And the first frame says vehicle 1 is moving across the ice at a very high speed toward vehicle 2. Vehicle 2 is at the edge of a cliff. Okay, that looks pretty similar to the movie. All right, let's look at the next frame. Vehicle 1 crashes into vehicle 2. Okay, this also happens in the movie. Now let's look at the last frame on the bottom. Vehicle 1 stops and vehicle 2 goes over the cliff. Well, that's a little different than the movie, right? So, is this what Claire wanted? Is this what she wanted to recreate? Did she want number 2 to go over the cliff and for number 1 to stop? Well, let's take a second to compare with the last one. So look at that last frame, both objects 1 and 2, and compare it to what we see here. Is that the same thing that's happening? So did Claire get the results that she wanted, and what went wrong? So you're going to respond to this now. So did Claire get the results that she wanted, yes or no? Okay, so I'm going to share out the results here. So we see that 34% of you, oh, it just changed. 30% of you say yes, that she did get the results that she wanted, and about 39% of you say no, she did not get the results that she wanted. So if you said no, if you chose B, then you are correct. She did not get the results that she wanted. So if you said yes, I want you to pay attention now so that you know what it is that you missed. So let's review what we saw here. So in Ice World Revenge, take a look at the image that you see. We have 1 approaching number 2. We have them colliding. And then in the last frame, we have 1, instead of pushing object number 2 over the edge, starts to move in the opposite direction. Claire wanted to recreate this, right? She wanted to see if she could make a movie based on this scene that she saw. Well, she tried to recreate it, and this is what she found. So take a look at the new storyboard. So on the left, we see object number 1 is approaching 2. There's a collision. And then this is the difference. These are the results that she got that she didn't want. If you see that last frame on the bottom, you see number 1 stopped and number 2 starts to go over the cliff, okay? You're gonna need to know this for the activity today. That's why I'm re-going over it. Okay, so now remind me, I'm gonna check for your understanding. What went wrong in Claire's test? So now we know that she didn't get the results that she wanted. What went wrong? Okay, good. So I'm getting a lot of the car went off the cliff. I particularly like Gage's response. He says what went wrong was the vehicle 2, so vehicle number 2, went off the cliff while I think he meant to say vehicle 1, while vehicle 1 didn't. Good. And then Cindy says when the collided car pushed the other car off while the other one stayed. Very good. Okay, yeah, no problem. All right, so let's move on. Very good. So I'm glad that you guys understand what the problem is. So Claire did not get the results she wanted. Vehicle 1 stopped and vehicle 2 went over the cliff. Very good. So in Ice World Revenge, the cars crashed, but the effect was that vehicle 2 did not go over the cliff. The effect has something to do with mass, velocity, friction, or a combination of these. So what we're going to be doing in this lesson is we're going to be trying to figure out why this happened to Claire. And they're telling us here that it has something to do with mass, velocity, friction, or maybe a combination of these things. And I want you to start considering what you think it might be that's causing Claire to have different results than she saw in the movie. So when Claire attempted to imitate this result, vehicle 2 went off the cliff after the crash. We aren't sure what caused these different effects. So here's our chapter question. We're on chapter 4 now. Why did vehicle 2 fall off the cliff in Claire's test of the collision scene, but vehicle 2 did not fall off the cliff in the film In Ice World Revenge? So we're comparing those two results. Well, here are our two claims. So take a look at these. These are the two claims that we're going to be trying to figure out which one might be true. So claim number 1 says, the vehicles in Ice World Revenge had different masses. In Claire's test, the vehicles had the same mass. Okay, claim 2. The friction of the surface that was used in Ice World Revenge was different from the friction of the surface in Claire's test. So claim number 1 means that it has something to do with the mass, and claim number 2 is that it has something to do with the friction. So I want you to think about which claim you think might be true just based on the storyboards that you saw. We're going to be looking at some evidence later that will help us. So if you need to, reread the question and the claims, think about them, and then tell me which claim you think is more likely true. All right, I'm going to share out our initial thoughts on this matter. I don't expect you to know the answer right now. This is just our predictions. So it looks like about the majority of you think B, meaning claim 2, that it has something to do with friction. And about 30% of you think that it has something to do with the mass of the cars. You think claim 1. All right. So we are going to be looking at some different evidence cards that will help us figure out which claim is true. So if you take a look at the image on the left, you see on the very top that we have all these evidence cards, A through E. And on the bottom, we have the storyboards. So in your workbook, you might notice that you have copies of all of these evidence cards and the storyboards. You're going to be using these in today's activity. And today's activity is going to set you up for an argument that you're going to write on Tuesday, sorry. Okay, so let's take a look here. So before you can figure out how the evidence might support the claim, you need to understand what the evidence card is telling you. So you can read and analyze each evidence card, but you also need to refer back to the movie storyboards. The next few slides will model how to do this. Okay, so let's take a look at evidence card A. Say there is a difference in, it says that there's a difference in vehicle one's velocity between the movie scene and the Claire's test. So let's read the evidence card, and I want you to think about where you, what claim you think this piece of evidence might support more, okay? In the crash scene in Ice World Revenge, Vehicle 1 slows somewhat before it collides with Vehicle 2. In her own test, Claire did not observe Vehicle 1 slowing down before the crash. Okay, so let's unpack that really quick. In the movie, the Vehicle 1, the one that's moving, it starts to slow down before it collides with the other car. But there was a difference between the movie and Claire's test, because in Claire did not observe Vehicle 1 slowing down at all before the collision. So I want you to think about which claim you think this might best represent, the one about mass or the one about friction. Okay, so from the storyboards, we can see that in Ice World Revenge, Vehicle 1 slows before the collision, and in Claire's test, there's no change in velocity before the collision. So you can tell by looking at the storyboards and specifically the velocity tails. So in Ice World Revenge, if you look at that very first frame, the velocity tails are longer than they are in the second frame. And that indicates that the velocity is decreasing, that it's slowing down. If you compare that to the second storyboard, Claire, it shows that both, and I mean, I know that this is kind of like hard to see because the image is really small here, but you can see, if you look closely, that, oh, just a second. It is my alarm for the gym again. Okay, let's see if I can multitask. So you can see that the two velocity tails in frame number 1 and frame number 2 are about the same length. So that indicates that the object did not slow down. Oh man. Okay. All right, sorry about that. Okay, so if Vehicle 1 slowed down before the collision in Ice World Revenge, that means that it experienced a velocity change. What causes velocity changes exactly? I want you to think about that. A force causes a velocity change, but what kind of force? What kind of force causes a velocity change? So what type of force would cause the object to slow down? What do you think? Okay, go ahead and take some time to answer that question. You can either sketch it out or you can add a text box. Okay, I'm gonna go ahead and share out one of the responses that I really liked. So here, Isabella says, friction would cause an object to slow down, and she is correct. Very good. Remember, we watched that video at the very beginning that showed us this. Friction causes objects to slow down. So a force in the opposite direction of an object's motion would cause the object to slow down, and we know that that force that slows things down is friction. So you are going to take some time now to read and annotate the evidence cards in your digital workbook. So right now, all we're going to be doing is reading the evidence cards. We're not going to be sorting them yet. We'll do that a little bit later. So go ahead and toggle over to the Zoom, and I'm going to show you the evidence cards. Okay. So you should see on page 3 of your workbook that there are a list of all these different evidence cards. Okay, we have A, B, C, D, and E. And right now you're just going to be reading and taking notes if needed. And remember that we're focusing on friction and mass. So you have all these tools that you can use to take notes if you need to. So let's read, we've already read evidence card A. What stood out to me here is that vehicle 1 slows somewhat before it collides. So I'm going to highlight that. So I'm going to click on this highlighter and I'm going to put that in yellow. And in her own test, Claire did not observe vehicle 1 slow down before the crash. So those are 2 important things to highlight in this evidence card, because this might have something to do with friction, right? Why would vehicle 1 in the movie slow down, but in Claire's test did not? I wonder if it had something to do with the surface. Okay, you can also add little notes if you need to. And you're gonna go through, read, take notes on each of these evidence cards, okay? And I'm gonna give you about, let's say, I think 7 minutes would be good to do this, okay? 7 minutes to go through, read the evidence cards, and take notes as needed. Okay, go ahead and start. So I'm going to go through and read the rest of the cards, and I'll just explain to you what I would annotate if I was doing it. So in evidence card B, it says, in Ice World Revenge, vehicle 2 moves slowly toward the cliff after the collision, stopping just before it goes over the edge. And in Claire's test, vehicle 2 went over the edge of the cliff at full speed. So what I did here was I just designated 2 different colors for each story. So Ice World Revenge is orange, and the key thing that I wanted to note was that vehicle 2 stopped. And Claire's test, this story is yellow, and the key thing that I wanted to note here was that vehicle 2 is at full speed. Okay, I'm going to move on to C. So the surface road for the vehicles in Ice World Revenge is clear and shiny. Claire's film professor says that the following materials might have been used. The friction of each substance is different. So all of these substances here are all shiny: ice, plexiglass, rubber, but they have different amounts of friction. Ice has a low amount of friction, plexiglass has a medium amount of friction, and rubber has a high amount of friction. So these are all important. So these are materials that might have been used in the movie. So I'm just going to highlight that. And I think that this entire table is pretty important. Yesterday, somebody asked me what plexiglass is. And if you've been to the grocery store recently, or I guess any kind of store, and when you get up to the counter to check out, you notice that there's like this clear plastic stuff that blocks you from the clerk. That's plexiglass. It's a very thick, strong glass. Okay, card D. In Ice World Revenge, vehicle 1 appears to move in the opposite direction after the crash, but it is off screen, so you can't see how far or fast it is moving. In Claire's test, vehicle 1 came to a stop after the collision. So in Ice World Revenge, I'm going to keep with my colors here, vehicle 1 seems to move in the opposite direction. And in Claire's test, vehicle 1 came to a full stop. Okay. Now our last card. Claire's film professor says these materials are commonly used for making miniature model vehicles. When painted, vehicles made from these materials all end up looking about the same. Okay, let's look at our substances. We have foam, plastic, and steel. These are all substances that could have been used for the model vehicles in the movie. So I'm gonna highlight this because this is telling us that these are the materials that could have been used. And they're also telling us the amount of friction that each of these substances has. So foam has a low amount of friction, plastic has a medium amount, and steel has a high amount of friction. So this is also, I think, important for us to know. So I'm going to highlight that whole table. Okay, so this is all I wanted you to do for that. So I want you now to return to the Nearpod. And we're going to move on with the lesson here. So what does the evidence tell you about how the force of friction might have affected each car's velocity change? So we just looked at these cards and we talked about the different amounts of friction surfaces have and that objects have. And I want you to also consider, what does the evidence tell you about how the mass of each car might have affected its velocity change? So you and it says partner, but I'm probably just going to put you into breakout rooms. So you and your group will now consider how the evidence cards connect to the claims. So this will help you decide which claim is overall best supported by the evidence. So notice now how we have an image on the very top that's new. So it has our question on the top and it has the two claims. What you are going to be doing in your workbook is sorting each evidence card based on which claim you think it best supports. So some evidence cards can stand alone to support a claim. However, sometimes it's more convincing and relevant to pair two or more evidence cards in order to support a claim. So basically what this is saying here is that one piece of evidence alone isn't really strong enough to make an argument. That's why we have so many different evidence cards. We want to see which claim has the most amount of evidence to support one claim, and that will help us argue our point. So we are going to read the question and the two claims. So we've already done that before, but let's just review. The question is, why did vehicle 2 fall off the cliff in Claire's test of the collision scene, but vehicle 2 not fall off the cliff in the Ice World Revenge film? Claim 2 is that it has something to do with the different masses. I'm sorry, claim 1 has something to do with the masses, and claim 2 has something to do with the difference in friction. So now let's go over an example with evidence A. And we're going to try to connect it to one of the two claims. So does this information suggest why vehicle 2 did not fall off the cliff in the movie? Was it something about the mass of the vehicles, or could this be something about the friction of the surface? So let's reread this evidence card. While I'm reading it, now I want you to have a different frame of mind. I want you to think about which claim you would sort this card under. In the crash scene in Ice World Revenge, vehicle 1 slows somewhat before it collides with vehicle 2. In her own test, Claire did not observe vehicle 1 slowing down before the crash. What do you think? Do you think that this has something to do with the mass of the vehicles or the friction of the surface? Go ahead and tell me now in the Nearpod. Okay, so based on the results that we have here, about 34% of us think that it would be B, and 26% of us think that it would be A, so that it would have something to do with mass. Okay, so now that we've discovered this, where would you sort evidence card A? Would you sort it under claim 1 or claim 2? All right, let's take a look at what we've got here. So about 26% of you think claim 2 and about 21% of you think claim 1. My personal opinion would be that I would probably sort evidence card A under claim 2 because it seems like if the object started to slow down in one and not the other, it probably has something to do with the surface. One of the surfaces is maybe has more friction than the other. So to sort your evidence cards, you and your group are going to discuss whether each piece of evidence supports or goes against each claim. You're going to place the cards underneath the claim they support, and you can also make new annotations on the cards if that's helpful for you. Okay, so now we're going to actually sort the cards. So we're going to sort the evidence cards by which claim they best support in the table in your workbook. So I'm going to go back to the workbook. If you would like, you could follow along with me on the Zoom so that I can show you what you're going to be doing. So you're going to scroll down. Notice how they also have the storyboards in here that you can refer back to. And I'm going to scroll down to this part where it says, why did vehicle 2 fall off the cliff? Blah, 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 our chapter 4 question. And we have our 2 claims. So this is the table where you're actually going to be sorting your cards, quotation marks, sorting your cards. Normally you would do this, you know, with the actual cards in hand, but we can't do that. So we're going to be doing it this way. Because I said that I think that evidence card number or letter A would go under claim 2, I'm going to do this, evidence card A. And you're going to continue to do this for each evidence card so that hopefully by the end you can kind of see which claim you think is most likely true. And this, remember, will help you on your scientific argument that you write on Monday. Okay. Chances are, you know, all the cards aren't going to fall under one claim. You'll have to think critically about where you think that they should go. Okay. So I'm going to give you about, let's say 10 minutes to go through and sort these cards. Okay. I'm going to put you into breakout rooms so that you can work with a group if you choose.